Welcome back to our videos on basic trig, and it's Joe again from Adult Education Centers in Winnipeg's North End, and I just want to let you know that you can download a PDF file of the notes that go along with the videos just by clicking on the description, the link with the description of the video. So before I start, I want to say thanks to Nancy for being our instructor at our PD Day, and Glenn for being supportive of this and rooting for me, and also I want to say thanks to Kevin for being the cameraman / producer, because I couldn't do it without him. So here we go. We're going to go back to this this right angles and intro to trigonometry package. And we are going to go to page 9. And page 9 is going to be titled Solving for a Length When Only One Angle and One Length Are Given. And so I have that on my flip chart here. So example 1, you'll notice here that we have a triangle, and obviously this is a right triangle. I'll make it more obvious right now. If I forget to put in those right triangle symbols, understand that this video is dealing with nothing but right triangles, okay? So we have a triangle. I've given you 10, actually let's just add a unit to that, centimeters. We have an angle of 59 degrees, and we have an unknown length over here that we'd like to solve. So really, if you look at it, there are, I've said on the page that there are 3 known values, but actually there are 4. We know a length there. We have an angle there. We know that length there, that's 90 degrees, and actually this is an unknown. So we have 4 pieces of information, 3 that we know, 1 that we don't know. And we're going to solve for that length x. And it would make sense that x is going to be in some number of centimeters as well. So, following the steps that I've written down here, step 1, circle the angle of interest and name the 2 sides, okay? So the angle of interest is this one here. It's the 59 degrees. This one you could solve if you needed, but we're not interested in it. So 59 degrees. I'm going to name the other 2 sides. Okay, what 2 sides are we talking about? The ones with labels, either this one or that one. This one over here, this hypotenuse, we're not interested. So we're only looking at the 2 sides that are in the question. So like that. So this x, what is that relative to the 59 degree angle? Well, it's the opposite. And what is the 10 relative to the 59 degrees? Well, it's the adjacent. Hopefully you can see that on the video. So, opposite and adjacent. Now, you should always be working with some sort of a little chart that tells you the definitions of sine, cos, and tan. So I'm going to assume that that you have that sitting in front of you. If you're in our actual math class, you'll see them posted all over the walls and whatnot. So we have opposite and adjacent, and we know that step 2, it says determine the trig function. You know that that is going to be tan. So, the function that we're talking about is tan. Now, let's just continue and see what it says next. It says set up an equation. Okay, well, here's our equation. I'll just come over here. We have tan 59 degrees is equal to opposite over adjacent, and opposite over adjacent is going to be x divided by 10, and I'll take my calculator here, and I'm going to need to know what the tan of 59 is. So I'll go 59 tan, and I'm going to take that to 4 decimal places, so it's going to be 1.6643. Now I'm going to keep that number in my calculator. Now you know that by looking at your calculator, it doesn't say 16643, it says 1.66429 and so on. But I'm just writing it down to 3 decimal places. But I'm still holding that long number in my calculator. Now I need to solve for x. Now we need some basic algebra skills here. So the thing that's standing in the way of x being all by itself is this 10. Now that 10 is a divisor, so what we're going to do is we're going to just come in. I'll come in with a different color here. We're going to come in and we're going to take that 10 away from that side, but guess what? It's going to have to come out the other side. Now when you take something divide by 10 and then multiply by 10, it falls away. And when you're multiplying by 10, it's easy. You don't even have to use a calculator. You just go, oh, you're multiplying by 10. Oh, the answer must be 16.643 is equal to x. Now, I just want to take a look at this value here. This value is taken to 3 decimal places. Yet the value that I've been given up here, or that I gave you, was 2 digits, but 10. There's no decimal places whatsoever. So it would make sense that if this guy here is rounded to the nearest whole number, I would at the very most express this answer maybe to 1 decimal place. Okay, so in science there's all sorts of rules, sig fig rules and whatnot. I'm not going to get into those right now, but a good answer, a reasonable answer would be x is equal to 16.6 centimeters. Now, if you wanted to take a piece of paper and draw 16.6 centimeters down this way along maybe your paint margin, and then draw exactly 10 centimeters that way along one of the blue lines, and then attach the ends and come in, you can check that that's going to be about a 59-degree angle. Now you know those are just dollar store tools we're using. We're not using high fancy tools. Okay, so your degree that you might measure might be 58, might be 60, but it's in that neighborhood. You can verify that that's actually going to be the case. All right? Okay, so we're going to flip to the next question. So now would be a good time to pause and ask questions if necessary. Otherwise, we will go to page 10. And page 10 looks like this. This is example 2. And every example that I make is slightly different than the one previous. And I've got 35 degrees here. I've got a question mark right there. I've labeled this one, this vertex as S, Q, and R. And there's my right angle. And I'm asking you to solve for SQ. SQ is this length right here, the hypotenuse. I've also shown it by a question mark. Okay, so if we follow the directions that you see on page 10, step 1 is the exact same as the last one. It says circle the angle of interest and name the two sides, okay? Well, again, the angle of interest is right there. Name the two sides. Oh, by the way, I'm missing the 12.1 here. This should be right there. Okay, now I've just not bothered to write down inches, feet, meters, whatever. I'm not going to clutter up my diagram any more than it needs to be. Okay, so there's the angle of interest, and I'm going to name the two sides. I'll point to the two sides first. So I'm interested in this side, and I want to know this side. So, what are the names of the sides? Well, we have 35 degrees here, and we have this length. Now this length is touching, is part of the angle. It's the adjacent. The longest side is always the hypotenuse. And remember, the longest side is directly across in the right angle. So this is the height. So we have a triangle, and we've got information on the adjacent and the hypotenuse. And so adjacent and hypotenuse, they suggest cosine, or cos for short. So we determined the trig function, sorry. So now we're going to set up an equation. So cos, well, you don't just have cos, you have to have cos of an angle. And in this case, it's cos 35 degrees is equal to adjacent over hypotenuse, and that's part of the battle there. And what is cos 35? Well, I can approximate it, but I think what I'll do here is I'll go into my trusty calculator. Cos 35 is 0.8192. Okay, and again, it's not exactly that, but we're rounding to 4 decimal places. So 0.8192. Now the adjacent is 12.1. And the hypotenuse is our question mark. We could have used anything to represent the unknown. We could use x. I use question marks a lot. I could have used SQ, whatever. Anything to represent the unknown. So in this case, I'm using, as I say, I'm using the question mark. Now, before we proceed with that, I want to take you over and introduce you to a little concept that you're going to need to know. Hopefully this green shows up here. So we're just going to step aside for a minute, okay, and then we'll go back and finish the question. If I want to solve for an unknown that's the bottom of a fraction, there's a very simple way to do this. But I want to prove to you that the way works, and then once you accept the proof, then you just take it and use it as a tool from now on. So watch this. I'm going to say that 4 is equal to 8 over 2. Okay, so anybody who knows anything about basic fractions will know that 4 is equal to 8 over 2. Now, I'm going to take these two numbers. I'm going to take the 4, and I'm going to take the 2, and I'm going to interchange them. I'm going to interchange them, and this is what I'll have. 2 is equal to 8 over 4. Notice it's still true. I could take any fraction, any number over another number that equals a third number, and I could interchange these two parts of it, and I'd still have a true statement. Okay, so if you're watching this, if you're actually with me on the live lesson, I would go through a couple more of these just to verify. But for now, I'm gonna use this as sufficient proof that I can actually interchange these two. So based on this, what I did in green, I'm going to go and use the same principle over here with my equation. Okay, so I'll just go back to here, and I'm going to go like this. I'm going to take this as my unknown. I'm going to put it over to the side. And I'm going to put this guy on the bottom. So 12.1 over 0.8192. Now I've got my variable all by itself, which is what I want, and I've got a couple of numbers, and they look kind of messy, but that's okay because the calculator doesn't care how difficult the numbers are. So let's just plug away here. So I'll have to cancel my 0.8192 and start up here. 12.1 divided by 0.8192, and that's going to be another long mess. 14.8 I'm going to call that. So and technically, even though we don't have any units like centimeters, inches, or whatever, to be technically correct, you could say units. And that would make sense. Take a look at this. This is 12.1. Now, if I were to take that and go around like this, that would be about the same distance, right? 12.1. So it's a little more than 12.1, not a whole lot. And sure enough, it's not even 3 units more. So I try my very best to make sure that the sketches, even though they are sketches, that they're reasonably representative of what I really want. Okay? When I draw a 35-degree angle, I hope it's within a reasonable approximation. Okay, so that takes us up to the end of page 10. And there is a set on page 11. It's practice 1. And that gives you 5 practice questions. So now would be a good time to stop the video and take some time to work on those. The answer key is in the back. And I would round answers to 1 decimal place, and be sure to just write the word units after each answer, okay? So take the time to do that, and I'll see you later.